A very good afternoon to all the students. I am Dr. Hima Bindu from the Department of Mechanical Engineering in Institute of Aeronautical Engineering. I'll be dealing the subject robotics, and my today's topic is discussion on question bank from the module 4, that is about the trajectory planning. In the previous sessions we have discussed about module 1, 2 and 3 question bank, and today's class we will be discussing module 4, that is the trajectory planning question bank. Moving on to the first question. Describe the different path control modes in robot. Right? We need to describe the different path control modes in the robot. So as we can see in the figure here, we have a continuous path control and we have a point-to-point path control. And other than that, we have a linear interpolation description and the circular interpolation description and the spline interpolation description and a hybrid control mode description. So, firstly, what do we mean by the path control modes? What exactly is path control modes? Generally, this in the robot describes the movement of the trajectory, the movement of the robots in the form of a trajectory or a path. Right? The path control mode in the robotics generally is used to describe the movement of the robot in the form of a trajectory or in the form of a path control. So these particular modes generally are used to ensure the performance of the robot, which gives the accuracy and efficiency depending upon the application requirements. So here we can see the first figure, that is a point-to-point control. That is, here what is happening in this point-to-point control? Here this particular end effector will be doing a control. The movement of the robot's end effector will be done from one point to the other point and from one point to the other point, whereas in the continuous path control, there is the movement of the robot in the continuous form, in this particular form, right? In the path control, the movement of the robot manipulators and effector will be done from one point to the other point, and then to the next point, and then to the other point, the final point. Whereas in the continuous path control, see, this is the end effector which we are having, where it is moving from one initial position to the final initial position in a continuous process. So that is known as a continuous path control. So here the PTP, that is the point-to-point control system, generally is used to define the point to another. It is used from one predefined point to another, from one predefined point to another predefined point, and then to the other predefined point to the other predefined point in this form. That is the point-to-point control. The robot is being moving from one point to the other, focusing on the researching location, focusing on the specified location. Right? The robot's end effector will be focusing on a specified location rather than moving in a continuous form. In this particular form, rather than moving in a continuous form. The best example for this particular point-to-point control system is a pick and place operation, where we will be picking the object from one place and placing it to the other place. Or we can also take a spot welding, where the welding operation is being done at a specified spot, right? Where the welding operation is being done at a specified path. And the other tag which we can consider is between the points, which is not critical. It is the path between the points which is not critical. And one of the best advantage of using this point to point is it is very simple in use and speed. and it is also speed. As this particular robot optimizes movement to reach the target points very quickly. As we need to reach the target points quickly, when we are using the point-to-point control, the time is being reduced, the speed of the manufacturing process is being done fastly, and it is very simple in operation. Whereas we have one disadvantage is that the actual path taken is not being controlled, right? The actual path, whatever we are taking, cannot be controlled, which may not be suitable for these sort of applications, that is smooth and continuous motions. When we need to do a smooth and a continuous operation is to be done on any particular specified operation, this particular point-to-point control system will be a disadvantage as it doesn't have a control on the specified path. Clear? Moving on to the continuous path control system. Here, the movement of the robot will be done in a continuous, smooth points. Right? It will be done in a continuous, in this particular form, in a smooth path. Now, the robot's velocity, position and orientation are controlled throughout this particular movement. When we come across the continuous path control system, the robot's velocity as well as its position and the orientation are controlled throughout the movement. And the best examples for this particular continuous path control system is painting, spray painting, or welding, a continuous welding, or where we have the maintaining a smooth and uninterrupted motion, we come across the continuous path control system. It is like spray painting or welding operation, or when we need to have an uninterrupted smooth movement of the path to be taken place. There we generally use continuous path control system. But we have one disadvantage here is that this particular sort of the program is running very slowly and it is a bit complex compared to that of the point-to-point control system. Right? It is slow and complex compared to that of point-to-point control system. Right, one disadvantage of a continuous path control system is that it works slowly and the program is a bit complex compared to that of the point-to-point control system in order to have a predefined path. Next, moving on to the next type of the application is the linear interpolation description. What do we mean by linear interpolation description? Here in the linear interpolation movement path control system, the robot will be moving in a straight line between 2 points. Right? When we have 2 points, the robot will be moving in a straight line, maintaining a constant orientation as well as velocity. Maintaining a constant velocity and orientation. Right? The linear interpolation type of the path control system, the robot will be moving in a straight line from one point to the other, which is having a constant velocity and orientation. Generally, the best examples for this linear interpolation description is that maintaining a straight path. Whenever we require, the robot needs to maintain a straight path, such as assembling components or performing machining operation. There we come across the linear interpolation type of the path control system. Right? Whenever we have assembly components and performing the machine operation, there we come across the linear interpolation type of the system where the robot is moving in a straight line from one point to the other point without having any sort of disturbances in between, maintaining a constant orientation as well as velocity. And the best, one of the advantage of this particular type of the path control system is that it is very precise and gives a linear motion, making it one of the ideal for tasks required to straight line accuracy, right? When we are using this particular type of the control system, the accuracy is good. The accuracy is good, as well as it gives a very precise linear motion. And one of the disadvantages is that again it is complex in trajectory, as it has to move in a straight line path. So it is best suitable for complex trajectory. So that is one of the disadvantage when we are using a linear interpolation path control system. Next, moving on to the next one, that is circular interpolation system. Circular interpolation system means where the robot is being moving in the circular direction or in the form of an arc. It is moving either in the circular direction or in the form of an arc shape between one point to the other point, right? Between one point to the other point, maintaining some constant radius. Maintaining some constant radius, right? The robot which is moving in a circular direction or in an arc-shaped path between one point to the other point, which is maintaining a constant radius and orientation, is known as circular interpolation path control system. The best example for this particular circular interpolation path control system is cutting circular shapes. Cutting of the circular shapes, or drilling operation, right? Inspecting round objects, or performing arc welding. Operation, right? The best example for this particular circular interpolation is drilling operation, arc welding operation, or inspecting the round objects are the best examples which we can consider for circular interpolation path control technique. Now, the advantage of this particular type of the technique is it gives a very smooth circular motion, as well as it requires a precise curved path. Right? The best advantage of using the circular interpolation is it provides the smooth circular motion. Not only that, this particular task gives a very precise curved path. And one of the disadvantages is that it is limited to use in more complex moves. Right? This particular type of the interpolation method is limited to use because it is moving in the circular motion. So it is more complex in motion, right? It is limited and it is more complex since it is restricted, as the robot's manipulator is restricted to circular as well as the arc-shaped paths. Next, the fifth one is the spline interpolation. Spline interpolation is nothing but whenever we require to have a continuous curve that passes through a series of predefined points. For example, one point, other point, we have another point here, right? Whenever we require to have a smooth predefined continuous curve with the predefined points, the curve is defined using the mathematical function like B-spline. Right? With the help of the B-spline or Bezier, the robot will be moving in a smooth continuous curve from one point to the other point, that is a predefined point, in a mathematical function that is known as a spline interpolation path control system. Generally, we use this particular type of the system in CNC machines, in complex assembly operations, etc. This is ideal for complex path applications. Whenever we have a complex applications like CNC machining or complex assembly operation, then we come across this spline interpolation type of the technique. And the advantage of this particular type of the interpolation is that it gives a smooth transition between the points. This particular transition, what we are seeing, is very smooth between one point to the other point, though it is complex and it is more flexible in nature. Right? This particular type of the control path system is more flexible in nature. But the disadvantage is that it requires more processing power and time. In order to move from one point to the other and from one point to the other, the time consumption is more. The time consumption is more, as well as the power consumption is also more, which is one of the disadvantage of using this spline interpolation method. And the programming is also very complex when we need to run this spline interpolation type of the path control system, right? Next, the sixth one is the hybrid control mode. Hybrid control mode means, as we can see in this figure, this particular type of the robot is moving in a linear interpolation with circular interpolation depending upon the task. That is, it is the combination of both point to point and continuous path control. That is, the combination of both this is known as a hybrid control, which has been taking place in this particular point. That is, it takes place from one point to the other point, or it is also a continuous movement of the robot which has been taking place to perform any particular task. Depending upon the requirement of the task, this particular hybrid control mode will be operated. Whether we want a point to point, then it will be operated in a point to point. If we want a continuous path control, then it will be operated in a continuous control. That is, any robot which is having both these path control systems, that is a point-to-point control as well as a continuous path control system, is known as a hybrid control modes. The best example for this particular hybrid control mode is the combination of straight, curved and point-to-point movements. That is, any robot which is having an advanced robotic system where the task required is for combination of straight curves and a point-to-point movement, there we will be using this particular type of the hybrid control type of the robot. The best advantage of this particular robot is it is very versatile and adaptable for complex tasks. It is very adaptable for complex tasks and it is also versatile to use. And the disadvantage is that it is very complex in programming and controlling and requires advanced algorithm and control system, because it is a combination of both the control systems. So the programming is complex as well as it requires a more control system and it requires advanced algorithm to be inserted in the robot to perform two tasks simultaneously. Next is the reactive and adaptive path control system. What do we mean by reactive and adaptive path control system? The robot which is adjusting its path based on the real-time feedback from sensors and allowing it to adapt to change in the environment or unforeseen obstacles is known as the reactive or adaptive path control system. That is, any robot which is being adjusted and which is allowing itself to be adapted to the changes in the environment based upon the sensors being placed to the robot is known as the reactive path control system. And the best example of the reactive path control system is the autonomous robots, such as those used in search and rescue operations, or the robots which are used for service robotics, or the robots which are used in industrial automation. There we use this particular type of the reactive path control system. Generally, the robots which are used in the industrial automation or in any sort of rescue operations or in any sort of service robotics, there we use the adaptive path control type of the system. And the advantage of using this particular type of the system is that it operates in dynamic as well as unpredictable environment. Right? This particular type of the robot will be operated in dynamic as well as unpredictable environment. That is, in any of the circumstances, this particular type of the robot can be used, whether in the hot areas or in the cold areas, or where we can't predict the environment constraints. There also we can use this particular type of the robots. But one disadvantage is that we require to have a processing capability which can increase the cost and complexity. When we are using this particular type of the robot, its cost is more and complexity is also more, as the algorithm written to work for this particular reactive path control system is more complex, right? And it not only that, the speed and environment adaptability and balancing factors like precision requirements of the robotic task or path control modes are chosen based on the specific requirements, right? Not only the complexity or not only the increase in the of the cost, or not only about the complex algorithm being inserted in the robot, but we also need to constrain about the speed, environment adaptability, the robotic task, and the precision. Balancing factors of the robots are to be considered. These are few of the disadvantages which come under the reactive or adaptive path control techniques. Right. So this was about the different types of path control techniques, that is about reactive or adaptive, hybrid control modes, spline interpolation description, circular interpolation, linear interpolation, the continuous path control, and point-to-point control. So these are few of the modes with the help of which the robot's manipulator will be moving from one point to the other point based upon the different types of the application, based upon the different task applications, right? Moving on to the second question, explain the path planning with a block diagram, right? Here we need to explain the path planning with the help of a block diagram. So how will we draw the block diagram for this initially? Yes, first is the environmental representation, right? First we will be drawing a block diagram as N. Environmental representation. Next is the goal, right? Next is the goal definition, path planning algorithm. Next is the path planning algorithm, followed by path optimization and motion planning. Motion planning, execution, and the last one is, and then is the feedback, right? So this is the block diagram of the path planning. That is first what we do. Path planning is nothing but the critical components in the robots, where the autonomous vehicle and many other systems that require navigations will be using this particular sort of the planning system. Generally, it involves the optimal path for a robot or a vehicle to move from a starting point to the target destination while avoiding the obstacle. When any particular robot have to move from one initial position to the final initial position. For example, we have the obstacles being placed here, right? So how it is traveling, that is important. That is known as the path planning. So generally it is based upon the environmental representation. That is, the environment is represented in a way that the robot or vehicle can understand. This could be a grip map or a graph, or based on a 3D model. So what is the input which we can take, which we consider here for the environmental consideration? That is a map or an environmental model. And when we come across the output, it will be the representation of the environment, including the obstacles and the free spaces. Right? When we come across the goal definition, it is generally used to target or destination is being defined. Generally, where we have a target or the destination is already been defined, there we come across the goal definition. That is when the user or the system is defined to some target location. Right? When the user or a system is being defined to some target location, or the output whatever we are getting with this particular goal definition is nothing but the destination point. Right? That is when we need to move from one place to the other, we need to have a destination point and we need to have a target point, initial point and the destination point. So when we are placing that, we will be getting the goal identification. Next is the path planning algorithm. Path planning algorithm means we need to write the algorithm which has been inserted into the robot, and based upon the path planning algorithm, the robot will be acting from initial to the final position. That is an algorithm which is used to calculate the optimal path from the start point to the goal point, that is the final point, avoiding all the obstacles, is known as the path planning algorithm. And that particular path planning algorithm is known as the Dijkstra's algorithm and rapidly exploring random RRT algorithm. Right? It will be including the RRT or the D algorithm in the programming side. That is, the input will be the environmental representation and the output will be the planned path which we will be getting. Next is the path optimization. Path optimization means what here? The path optimization means the initial path may be optimized for distance and the energy consumption or the time or other criteria. That is, path should be initially planned and then it should be optimized. The output will be the optimized path. Right? Next is the motion planning, in which motion direction it is being moving. That is, the robot or a vehicle when it is being converts the path planning into the actual movement commands. That is the optimal path. Input will be the optimal path. Output will be the movement commands. Execution. How we execute that particular planning. Where we have already done the path planning. How it has been executed. That is movement commands, and the actual movement along the path is the final output which we will be getting. That is, any robot or the vehicle which is following the movement commands to reach the destination is known as the execution. Right? That is environmental representation, goal definition, path planning algorithm we need to write, then we need to do the path optimization, then the motion planning, execution, and final one is the feedback and replanning. Feedback and replanning means during the execution, if we have any feedback given from the sensor, if there are any mistakes being occurred by the new obstacles being detected, so that will be sent as a feedback, and again this particular programming will be replanned and started once again. That is, with the help of the sensor feedback, the program will be sent back in the reverse direction. The replanning of the path will be done. That is, first initially environmental representation to the goal, then to the path planning algorithm, then to the path optimization, then to the motion planning and execution, and the final one is the feedback and replanning. This is about the path planning block diagram. Next, the third question is differentiate between joint space and Cartesian space. What do we mean by joint space and what do we mean by Cartesian space? That is, the joint space is nothing but it refers to the space which is known for the robot joint angles. Right? The joint space is nothing but the space which is used to define the robot's joint angle. Each dimension in the joint space is based upon the position of the robot joints, whether it is an angular position or whether it is a displacement type of the position. The position which is being determined corresponding to the position of the robot joints is known as the joint space, and it's mainly considered based upon the individual joint variables like angles of for revolution joints or linear displacement for prismatic joints as coordinates. When we come across the control system, this particular type of the joint space is being controlled with the direct commands where the joint angles or the positions will be controlled directly, and it is very simple in operation, and the control algorithms in the robot movement are directly related to its joint settings, and the usage of this particular type of the joint space is nothing but it is used in the Cartesian space in less critical direction, and it also gives precision in the movement of the individual joints is required or when the robot path is in Cartesian space. Coming to the Cartesian space, the Cartesian space generally refers to the space which is being defined by the robot's end effector position and orientation in the environment. It is used as a global coordinate system for x, y, and z coordinates. Right? For the x, y, and z coordinates, the Cartesian space plays an important role in the space defining the robot's end effector position and orientation in the environment. And this is generally a coordinate in a three-dimensional space where we have roll, pitch, and yaw, where we will be describing x as the roll, y as the pitch, and z as the yaw. And this is used to describe the position and orientation of the robot's end effector. Right? When we come across the control of this particular Cartesian space, it is generally used to describe the position as well as the orientation of the end effector, where the system which computes the necessary joint angles to achieve this position, which requires solving inverse kinematics. And the usage of this particular Cartesian space is that position of the end effector in the space is critical, such as in tasks involving the precise position or when interacting with objects in the robot environment. So these are the differences which we have gone through. So in today's class, we have come across the discussion on question bank on the concepts like path planning, different types of path planning systems, and about the joint space and Cartesian space, difference between the joint space and the Cartesian space system. So in the next class, we will be discussing about the question bank for module 4, that is the application of robotics, how the robot is being applicable and what are the various modes where the robots are very important. Right? Signing off for today, Dr. G. Hima Bindu. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.